Eric from NINGBO PROCOLOR. Today, we would like to give you a lesson for essential requirements of plastic colorants, heat resistance. The definition of heat resistance is no obvious change of color shade, color strength, and property at a certain processing temperature and time. The biggest difference between plastic coloring and ink paint coloring is most of the plastic coloring molding has a heating process. The structure of colorants will be destroyed in the plastic molding at a high temperature. Not only color changes, but also affect its light fastness and migration. So heat resistance is one of the most important index for plastic color. In the early days of the plastic industry, processing temperatures above 200 degrees are rare, but now 300 degrees or higher is normal. The processing temperatures are different for each kind of plastic resin. Honestly, it is meaningless to require all current to reach 300 degree heat resistance. Normally, the heat resistance of inorganic pigments is excellent. The organic pigments and dyes are much lower. Therefore, it is very important to choose suitable colorants through heat resistance index. At the present, many colorant suppliers test the heat resistance of each pigment in different plastic resin according to the method of EU standard 12877-2, so as to provide reference for customers. The method provides that at 200 degrees as a benchmark, use injection molding machine make a standard color paint at a certain concentration. After each time interval 20 degrees, residence time 5 minutes after injection to get a color paint. When two plates of color difference delta E equals 3, this temperature will be heat resistance index at the concentration. As shown in the figure below, pigments in 220 degrees and 240 degrees, color difference delta E is 0.5 and 1 compared with 200 degrees. And it is in 260 degrees, color difference delta is 3 compared with 200 degrees. So its heat resistance is 260 degrees. At present, the heat resistance index provided by many colorant suppliers refers to 1/3 standard concentration, which is not equal to the heat resistance of the colorants at all concentrations. It is well known that the heat resistance of colorants declines with the decrease in dosage. We need to pay attention to heat resistance index in color mentioned for plastic. The heat resistance is related to the chemical structure. Generally speaking, inorganic pigments are metal oxides and metal salts, which are the reaction products of high temperature calcination with the calcining temperature up to 700 degrees. Therefore, the heat resistance of inorganic pigments is much higher. The heat resistance of organic pigments and solvent dyes is closely related to their chemical structure, just as the molecular structure of pigment directly determines their color and the property. The molecule skeleton of pigment varies with its atoms, which will affect the pigment stability of the molecular skeleton and the decomposition reaction under certain temperature. Organic pigments, according to its chemical structure, can be divided into many types as shown in the figure. Different chemical structure of the pigments also have different heat resistance. The below table shows heat resistance of different structure pigments in HDPE. Heat resistance of azulate pigment yellow 62 is 250 degrees. DDP pigment red 254 is 300 degrees. The heat resistance is related to the dosage. Pigment's heat resistance is different under different concentrations. You can see very clearly from the image below, some good structured pigments such as the yellow metal lake. Its heat resistance do not go down when color concentration down. Current heat resistance state under different concentration is very important for plastic colorists in their daily work. It is not only in light tones that require a very long concentration of colorant, and when doing color matching, maybe the concentration of colorant is lower. So we can only put the colorants which heat resistance does not decline with the decrease of concentration into use. The plastic colorist should find out the suitable colorant in the range of processing conditions and confirmed by testing. At the same time, it also provides some basis for the adjustment of industry production process. Colorists should choose cheaper colorants to reduce cost and make the enterprise better in the tough market competition. There are two series of quantitative studies for heat resistance. The results are expressed in the form of chart. Thanks for watching.